moving on to our third day of lesson 7.4, we are still working with these exponential functions. So now we are going to be writing equations from word problems of exponential functions. Okay, it's going to be very important that we use our notes from yesterday or from the last time you took notes, because we are going to be using these right here. Those are going to be very, very, very important. So we'll go through a few examples and we'll see how it goes. It says a house that costs $200,000 will appreciate in value by 3% each year. Write a function that models the cost of the house over time. Use X for years and Y for the value of the house in dollars. So we're going to start with this first section. Basically, what this section is asking you to do is to write an exponential function to represent the situation. We know that an exponential function is in the form of y equals ab to the x, where a is your initial value, b is your growth or decay factor. Okay? So we know that in order to write an equation, we need those two things. So let's first start off by deciding if we're going to be dealing with growth or decay. It says a house that costs $200,000 will appreciate in value by 3% each year. The word appreciate suggests that we are going to be dealing with exponential growth. Okay? Now, this is where it gets a little bit confusing, because when you are writing an equation for an exponential function, you need the factor. But most of the time in these word problems, they're actually giving you the rate. So they say that it's increasing at a value of 3% each year. That's not the factor, that's the rate. Okay, so it's very important. So this is the rate. Very, very, very important information. So we'll start with what we do know. Y equals A. Well, my initial value, the house costs $200,000. So there we go, 200,000 times B to the X. So we're going to look back at our notes from yesterday. Remember I said that they give you the rate. So if they give you the rate, you're going to be following some equations. Let's list those equations here. If you're dealing with growth, we know the factor is going to be equal to 1 plus r. If we're dealing with decay, the factor is going to be 1 minus r. So in this case, in order to find our factor, we know that our rate is 3%. Well, how do we write 3% as a decimal? 0.03. So B is equal to 1 plus 0.03. So therefore, my factor, my growth factor, is going to be 1.03. Okay, again, it is important to remember that they gave you the rate in this problem. Because they gave you the rate, that is not, you do not just put 0.03 in for the factor. You need to use the equations to find the factor in order to write the full equation. Let's go ahead and move on to example number 6. We'll look at example number 6. Okay, so since Jacorin is 60 inches and going through a growth spurt, for the next year his growth will increase by 1% each month. So obviously we're dealing with growth. It says write a function that models Jacorin's growth spurt over the next year. Use X for months and Y for the height in inches. So we know an exponential function is Y is equal to A times B to the X. A is the initial value, B is the factor. Okay, well let's fill in what we do know at this point. We know that he starts at 60 inches. So my initial value is 60 inches. We do not know the factor at this point. Okay, because what did I tell you that they usually give you? If they give it to you in a percentage, they are usually giving you the rate. So we need to look back at our equations. Okay, we're dealing with growth. We have a rate of 1%. So we go to growth. B is equal to 1 plus R. So what's going to be filled in here is equal to 1 plus R. In this case, R is 0.01. So my growth factor is 1.01. Okay, so let me back up for 1 second here. So we easily found the initial value. Okay, they usually give it to you. But it was a little bit more difficult to find the factor because they gave it to you as a rate. So you needed to use your equations that we have to find the factor when given a rate to write your equation. Okay, so now we have 1.01 as our factor. It says find his height at the end of the year. Okay, so it looks like it's by month. How many months are in a year? Well, it's going to be 1.01 to the 12th. Okay, take out your calculator, do 1.01 to the 12th, and you should get 1.1268, and then multiply it times 60. Remember, order of operations would tell you that you need to do those exponents first. That's why we did those first. And your final answer should be about 67.6095 inches. Okay, that would be his height roughly at the end of the year. Moving on to example 7. It says Ian's new Mercedes cost him $75,000. Well, easy enough. That is obviously going to be our initial value here. So I'm going to put that in right now. From the moment he drives it off the lot, it depreciates. Okay, depreciate to me means decay. Okay, so it goes down by 20% each year. Okay, so it decays at a rate of 20%. I cannot just put 0.2 to the x in here because they gave me the rate, but I need to fill in the factor, so I'm going to follow my equations. So I go to decay. My factor is equal to 1 minus r. B is equal to 1 minus 0.2, which is 0.8. So it's actually going to be 0.8 to the x. Remember, when they give you a percentage in these word problems, they're giving you the rate. You need to find the factor in order to write the equation. So we wrote an equation. Y equals 75,000 times 0.8 to the x. Now, what will the value of the car be at the end of 5 years? Well, the x represents the number of years, so all you need to do is plug in 5 there. So let's take our calculator and do 0.8 to the 5th times 75,000. And you should get roughly 24,576. So we've gone through 2 growth examples and 1 decay example when you are given the rate. There are times, however, if we flip back to, let's go to number 2, where actually they will give you the factor. Okay, so if they give you the factor, you can just fill in the factor. It says the most recent virus that is making people ill is a fast multiplying one. On the first day of the illness, only 2 virus bugs were present. So that's the initial day. So 2 times b to the x. Each day after, the amount of bugs triples. Anytime you have a problem where it says triples or half or quadruples or doubles, you are just going to use this. That is your factor. Okay? You don't have to worry about taking the rate and finding the factor or vice versa. They give it to you. Triples, so 3 to the x. Okay? Same thing down here. It says Tobias ate half a banana in his room and forgot to throw the rest away. That night, 2 gnats came to visit. Each night after, there were 4 times as many gnats hanging around the banana. So y is equal to the 2 that were initially there times the 4 times as many gnats each night.